We're, we're going to talk about one type of graphing problem, which is going to be the race car problem. And you're going to picture yourself as a car going around the racetrack. And when you do that, you're going to be varying your speed depending upon if you're going into a curve or pulling out of a curve. And so when you look at the racetrack, you're going to get gradually faster. You're going to slow down at the curve, pretty much go at a constant here. When you pull out of the curve, you're going to speed up, go at a constant, slow down, go at a constant, and then eventually speed up again. And so that's going to repeat. Your job is going to graph this in terms of total distance based on time or as a function of time, and then the crow's distance based on time. And the crow's distance is where you're starting with a point at the starting point, and then you're flying to each of these points as you go through. So that would be the third question on this problem. So we're going to do number 1 and number 3 together on the same graph, because this says as a function of time and this says as a function of time. So our x-axis is going to be the same, and therefore we can have a relationship between the y-axis as well. And then we'll come back and do the second problem. So when I look at this, I'm thinking about the total distance. Now I put in letters A, B, C, and D, and S to help me have some sort of reference points in the graph. So when I look at this, my S, A, B, C, D, and S refer to the time at those points. And then on my y-axis, it's going to be the distance from the starting point, the total distance. So when I go from the starting point to my point A, I'm going to eventually get faster and faster, faster. You're not going to go a constant speed. So you're going to pull out of that, and then you're going to go up to A at a certain speed. And then from A to B, you're going around the curve. And around the curve generally is where you're going to be maintaining a constant speed, let's say. Constant speed means it's going to be a straight line. So that's going to be something like this, and sometimes you can put the point out so you know where you're going. And then once you get to B, you're pulling out of that curve and eventually speeding up quickly and getting into the back stretch. So this speed from B to C is going to be a faster speed than what it's seen before. So you want to have an increase a little bit higher, and again, you're going to be accelerating out of it and going into that curve, and that was a little bit misleading because that showed that it was increasing like consistently. It's more going to be increasing at the beginning, and then it's going to be leveling off into a straight line like that. Probably be a little decrease going into that curve at C, and then a constant to D. Now, one thing that you can kind of see is that from A to B is going to be the same exact thing from C to D. It's the same speed, the same curve, so it can repeat itself looking like this, and then again, you're going to be pulling out of this and going to the starting line. So it does have repetitive parts to it, and there are some real subtleties to it as well. So that would be the total distance. We don't really have any distance markers on the side. But now we can think about, what about the distance a crow flies from the starting point to all of these other points? So again, we're going to do the same thing. I'll do this in red. So distance a crow flies at those same points. Now, what I want to do on this one is go back to this particular graph and see what I'm talking about. Now, I thought it would make sense to put in some arbitrary numbers in relationship to each other, meaning if I labeled this as, let's say, 3, this is going to be a little bit more 4. This would be a little more than 4, so it's got to be like 6. And then this could be slightly more than 4. Maybe it's the same length as B. Maybe so I go back to 4 instead of 5. That would make a little bit more sense. And then go back, and again 3, 4, 6, 4, and then back. Because again, the way the crow flies, it'd be kind of the same. So notice what happens. You're going at constant rate the way the crow flies, the same as the direction of the car, total distance at the beginning from S to A. And then what's happening is you're actually going to be under the total distance. The total distance is this plus this as you go along, but as you take that shortcut, it's a smaller distance. So the way the crow flies should always be at the line or below the line of the total distance. It'll never be higher than that total distance. And then we go through and we look at it. So I'm going to remember 3, 4, 6, 4, and then back to 0 for the way the crow flies. And I'm going to try to make sense of that back here. So starting at S, this is going to be in red. It's going to be the same exact thing as the total distance going up to point S. Now we're going to think of A to B. A to B is going to be less than the total distance. So now I'm going to have a point here that's going to be increasing from A to that point. Actually, I should probably make that just a little bit more obvious. So I'm just going to keep that underneath there a little bit. And the reason I do that is because along the back stretch, you're going to see that, look what happens. This gets a shorter distance as you go, and then all of a sudden it picks up a longer distance. So from here, it gets shorter and then longer. So that means that really you're going to be coming down and then eventually going back up. So let's say that that goes like this and then comes back up like that. Then you get from C to D. What happens from C to D? You're actually decreasing. So that's going to come back down. We said it was 4, which should have been the same as that one. So it'd be kind of like this. And then on the home stretch, it goes down to 0. Now, I'm going to put in the numbers on here to remind me of what I just thought of before. And the reason why I'm putting in numbers is because of the third graph that we're going to draw. All right, so far we've got an understanding. I mean, it's not perfect, but we see how they're related. The next question is going to be a little bit more confusing because it says, for number 2, sketch a graph of the car's distance to the starting line as a function of the total distance traveled. X, total distance traveled. Y, car's distance to the starting line as the crow flies. So we need another graph for this one. And you're going to see that the x-axis is total distance, the y-axis is distance the crow flies. This is a hard graph. I struggle with knowing what this is going to look like because to me, when I think about that x-axis, it's hard to make sense of that total axis, the total distance versus the distance the crow flies. So what I'd like to do is I would like to put numbers in this diagram to help me with the understanding of the other ones. So again, these are just relative numbers that I'm going to use to help me. So if I look at 3, that's the same. At this point, it's going to be a little bit higher. So let's say that's going to be 5. This one's about double, 12. That one a little bit higher, maybe 15 and 20. Now, if, again, I'm looking at in comparison to these, I'm writing in here. At this point, you're going to see that you can figure out the ordered pair. Again, it's total distance for the x, the way the crow flies for the y. So you have ordered pairs now. Your ordered pairs would be like 3, 3. And again, it's black and then red. So it'd be 5, 4, 12, 6, 15, 4, and then 20, 0. And I can take those ordered pairs and put them on my last graph, and that can give me a good indicator in terms of what's going on. So when I do so, it'll be 3, 3. So this is now 3, and I'd have a 3 point here. Then I went and I got 5, 4, so it's going to be 5 and 4. And these are just my numbers. So 12, 6, 12 comes out here. $15, 4. And 20, 0. So you have now a graph of relating the two. I really think that's the easiest way to think about that. Now, that takes care of the graphs of the 3. Then there's a couple other questions that are the easier questions after you've gone through those 2. The first question is, where is the maximum distance away from the starting point on the first 2 graphs? Let's say if you take each graph separately, the maximum distance away from the starting point, the red one is obvious, it would be 6 because it's the highest point. But if you're looking at the black one, you're talking about total distance away from the starting point, it would be at this point, which would be 20 when it comes around. So, but the more interesting question is, what would the graph look like if you took 2 laps? So you want to think about each of these individually. What would it look like if you took 2 laps? The first one, if you took 2 laps and you're talking about total distance, it would be taking the same exact black graph and repeating it, but starting at this point and going up. Do you see? So you're repeating this, you're starting at 20, so you're going to be going back up, and then you're doing another cycle, but just a change in the y. The red line, if you repeat a second lap, it would be the same exact shape repeated itself on the same y, the same y's. But then you can have a little bit harder question on the last one. What would this look like if you were to think about having another lap? The answer is you would actually repeat going from 20 to 40, let's say, it would be starting on the x-axis and going down to the x-axis, but the y's are going to change. The y's are going to be different because the black line here is going to be different on the second half of this, same shape, but different, so it's going to be actually twice as big, twice as high as the green one, but the same exact shape going back down. Okay. Harder problem, really thinking through how to make sense of it. We were just given one object. If you just took the object and didn't put any numbers in or letters in, it makes it a lot more confusing in order to graph. So this finishes the activities on graphing with stories. Next week, we're going to be talking about different functions and transformations.